Thank you for joining us for another amazing show. We have a terrific guest for you today. We are talking about advanced optical communication systems today and how they can improve the reliability and performance of space-based communications. Welcome to the Tech and Space Leaders Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Matteo Vismara. He is the co-founder and CEO of SatEnlight. Welcome to the show, Matteo.
Thank you, Lisa. Very glad to be here.
Oh, absolutely. Thank you for making time to be here. Can we start by having you give just a little bit of background on yourself and SatEnlight?
Yeah, of course. I'm a physicist. I studied physics of matter in the University of Milano. And I started SatEnlight kind of by chance because I was the president of the Italian Association of Physics Students. And after a lot of events, organizing a lot of events also worldwide, I discovered being good in fundraising, and in the lab where I worked, there were 2 patents on this technology. And so together with the professors, we decided, okay, maybe it's time to put down these ideas and start a company. That's why it started.
Oh my gosh, that is an amazing story. So what actually motivated you to focus on optical communications specifically?
Yeah, as I told you, actually we in the optical instrumental lab that was guided by Marco Potenza, Professor Marco Potenza, Professor Bruno Paroli, and also Professor Milani. We had these 2 patents that came out of research we were, let's say, doing. And actually we got the need of the market in having, let's say, a technology that could enhance the data rates of the, let's say, available communication systems. So we started studying the business case, let's say, in the end of 2023, and then we started also with the POC that brought to the funding of SatEnlight.
Right, right. Of course, it seems like a lot of companies are talking about optical communications in space. What is the thing that is really helping SatEnlight stand out amongst all of these other players?
Yeah, actually, this is a question that usually, you know, a VC asks to me, because of course, right now the optical communication seems to be a wave. Actually, is a wave. There are a lot of companies arriving in the market with this, let's say, solution for the communication. So using lasers instead of radio frequencies. But here is the, let's say, value proposition and the competitive advantage of SatEnlight. We don't use the classical laser dot. The classical dot, we can thinking about lasers. We use optical vortices. So light that while propagates generates an helix. And why do we do so? Because different optical vortices are orthogonal each other. And this means that basically you can mount on the same satellite or the same transmitter 2 or more sources of 2 or more different optical vortices, code independent information on each of them, and send it through the same optical link, basically enabling a multi-channel transmission, because without our receiver that is patented, we are able to distinguish the different optical vortices and decode the information we coded on them, basically enabling this multi-channel transmission that increases the data rates and increases the security. But actually the value proposition is that this technology is a degree of freedom that is additive to what is already existing. So any optical terminal already existing on the market can benefit from this technology because we use this additive degree of freedom as an additive layer on what is already on the market.
Wow, that sounds amazing. Where are you in the development process? I understand you're TRL7, so what does that mean and where are you headed next?
Yeah, the TRL7 is the goal that we are going to reach by the end of the year with 2 tests basically that we are conducting right now. One test is related to the, let's say, demonstration of our technology in terms of robustness with respect to the propagation of the signal in a turbulent mean as, for example, the atmosphere. Because when talking about optical communications, there is one enemy, that is the, let's say, noise that this convective movement of the bubbles of hot air in the atmosphere can put inside the signal. So basically, you have to demonstrate that actually the signal is propagating without being degraded or destroyed by this turbulence. So we are doing these tests to show that actually our technology is able to mitigate these effects and still able to recognize the information on the laser. The second test we are doing, and with that one we will reach TRL7, is the test with drones, in order to show that our technology is able to recognize the information also when coming from a satellite, actually, so from a drone that will resemble the movement of a satellite that is moving on the head, let's say, of the receiver. So the capability of the system, of the receiver, to track and chase a moving object.
Wow.
Once we are obtaining this, we will go towards the, let's say, in-orbit demonstration. That will be the last step to go to the market.
Wow, amazing. And when do you think you'll have the opportunity to actually test the technology in space?
Yeah, we plan this in-orbit demonstration by mid-2028. We are already actively working on the planning for the spatialization of the, let's say, the system, the end-to-end system, in order to be ready for the 2028 mission that, as you know, are something that you have to plan like now or in some months.
Right, right. How has it been transitioning this technology? Obviously, you mentioned it came originally out of the University of Milan. How has it been transitioning from a physics lab to a commercial deep tech company?
Yeah, it has been, let's say, it is still right now a very tough challenge, because being a physicist, being a scientist in general, pushes you to, let's say, focus on the technology, focus on what is, let's say, the idea. But sometimes when you, let's say, hit the market, you understand that actually it is not the way the world is going. Because of course the technology is a thing, but the product is a different thing, is a different story. And so it has been a tough challenge, because you understand that still you can have a good technology, but if you don't have the right fit with the needs of the market, you are not going anywhere. And so as soon as we had the first money, let's say, we started hiring people that could help us in tailoring the solution on the needs of the market, defining the customer persona, defining what is, let's say, what are the pains and the gains of the people that we are going to address. So that was the first point that we had to understand. Then, of course, a kind of, let's say, drive that I already had, because I always had the feeling, also when I was a student, that science is not finished until you take the science you do into the Department of Physics, or in general in the research centers outside. You have to bring the technology to the people. You have to bring the technology to the world, in order that you can solve the problems that we are all facing. So it has been a drive that I always had, and I think that is the real, let's say, goal of a physicist. I think about, maybe, you know, Marconi, of course, and other great, let's say, physicists that turned to be also great engineers and that solved a lot of problems of the world.
Yeah, absolutely. What an amazing thing to aspire to. What do you think will be the early use cases that SatEnlight technology will be used for?
Yeah, of course, right now we still see a big gap in terms of downlink. There is, let's say, a huge demand for data rate in orbit. So, of course, optical communication is a thing already existing in orbit for inter-satellite links. But still, there is a big gap in terms of downlink. So, I think that we are going to have a big chance in this niche. Then I also doing some, let's say, doing some interviews and some researches. We also had the feeling that another use case is emerging very fast, and this is the field also of telecom, because actually right now we are all looking at the sky and talking about data center in space, talking about the moon. Of course, again, the GPS on the moon will be a very big chance for us, but still there are a lot of problems for the infrastructure here on the Earth, and I think that at the end the optical communication will be a solution that will be present in any aspect of let's say the communication infrastructure. So still the telco, even if a different market with different let's say way of thinking, will be a nice use case that of course is very near to us, more near than the space in terms of go-to-market and in terms of let's say development.
Indeed. So SatEnlight won the startup space competition during Satellite this year. What has that meant to your company?
Well, it was a big achievement because, first of all, I would like to again say congratulations to all the participants, because there were 10 startups that were like very high level. Just to tell you, the first competitor I had, he went on the stage and he was like, oh, I am coming out of let's say SpaceX, Google, and my CTO working at NASA, and I was like, damn, he's going to win. Because I mean, I'm a physicist out of the University of Milan, so where am I going? But when you go on the stage, you just have to enjoy, and I really had I really enjoyed, and I had the feeling that I was really arriving to the audience. I was arriving to the judges. So when let's say the judges and the whole organizers said SatEnlight won this competition, I was like really proud of all the work we've been doing, all the work that together with my team we did in the last, let's say, 2 years, because of course this goal, this prize, this achievement is of course a team let's say work. I was not alone on the stage, even if I were like I was presenting alone, but I was not alone in terms of what I was bringing to the audience. So it was really an achievement of all the work we've been doing in the 2 last years.
Well, congratulations on that. One of the things that we talked about a little bit earlier, but I want to dig into this a little bit further, is that many space missions really struggle with bandwidth ceilings and signal degradation. How is SatEnlight able to address those things?
Yeah, this technology that we patented and extended already in US, China, Japan, and the 18 European countries is a technology that leverages this property of light that is not yet used, that is called Orbital Angular Momentum. So basically they are optical vortices, and they are let's say vortices that are orthogonal each other. If they are different, okay, one from the other, they are orthogonal. So basically they are states of light, channels of light, one different from the other, on which you can code independent information and send them through the same optical link. So this basically is a multiplexing technology with which we are able to increase the data rates, first of all. Then, having this, let's say, a receiver that is patented, we are able to distinguish the different optical vortices, and it is something that other people without our receiver cannot do. So basically you are also increasing the security of the systems. And with that, we are achieving, let's say, a good solution. We are providing a good solution to these, let's say, use cases, for example, of space and telco.
Excellent. So how does the orbital angular momentum actually support those performance gains? And what can it deliver in terms of inter-satellite and space-to-ground communications?
Yeah, as I told you before, the orbital angular momentum is an additive degree of freedom. So this means that you can mount on top of the already existing solutions that you can find in the market. So basically, if there is, let's say, an optical terminal already achieving, I don't know, 10 gigabit per second, that right now is more or less the data rate we can achieve on the market, let's say we can find on the market, then you can multiplex the data rate. So basically you can put in parallel, for example, 6 different optical vortices, and achieve, for example, in the case of 6 different optical vortices, each one going 10 gigabit per second using the already available technology, you can achieve 60 gigabit per second. So in terms of, let's say, inter-satellite links, in terms of an infrastructure that is over and over stressed in terms of the data rate that is needed and the capacity demand that is increasing, this technology is enabling. Of course, again, in a use cases as the one of data center in space is something that is very, let's say, needed. Moreover, we can mount this, since this is, let's say, again, an additive degree of freedom, you can mount this technology on top of the already existing multiplexing solution, because basically we are using a property of light that is orthogonal, that is unrelated to all the others property of light. So it is orthogonal to the wavelength, it is orthogonal to the polarization. So still, you can mount it on top of any other system and enhance the performances of it. The integrability, and I conclude the answer, the integrability is not just this actually, because of course when you design a space, let's say payload and a space subsystem, you always have to deal with the multi-operability and the back compatibility. So when talking about the performances, of course I say that we are integrable in terms of, let's say, enhancing the performances of the system. But looking at the receiver, that actually is the core of our innovation, we designed it in order it to be integrable with the already existing network. So it will be a node that will be able to talk with the other, let's say, nodes already existing that are still using the classical shape of light, so the classical dot. So the receiver is able to communicate with the classical optical terminals, and is also compatible with the already existing optical ground station, because basically it is designed to be modular, and it can be, let's say, mounted on top of an already existing telescope, for example. Opening an ISMID door, you can mount it on top of it and gain, let's say, the enhancement of these performances through its use.
Wow, oh my gosh, that's amazing. Having worked in this field for a while, what are the most common misconceptions you've run into as far as optical communications go?
Yeah, actually, this is a very good question, because when thinking about optical communication, a lot of people always address the problem of chicken egg. We don't have enough terminals in orbit to, let's say, think about the adoption of an optical ground station or of an optical communication system, because actually, let's say, new technologies like this one always need a pioneer or some that really understand the technology and really believe the technology is going to disrupt the world. Still, I can, let's say, also say that when thinking about optical communication today, so let's say this idea, the idea of, let's say, chicken egg problem, is something that is coming from the people outside the world of optical communication. And actually, we have to be good enough in making it clear that the optical communication is the solution to the problem we are facing. Another misconception, in my opinion, but this is not a misconception, but still is a, let's say, point we should address more, and with we I mean all the people working in the world of optical communication, is let's say the hybridization of the network. Because of course the optical communication has some limitations. One is of course the need of line of sight, because of course you cannot communicate without the line of sight between the transmitter and the receiver. So basically, when a cloud is passing or when the weather is bad, you still have to rely on radio frequencies. So we have to think about a world that is not going to be completely wired, because of course it's free space, with lasers and optical communication. But about a world that is going to use optical communication as a solution that is going to allow you to download or communicate the world in very short time windows, but still as the need of a, let's say, background solution as the radio frequency. So the world is going to be hybrid, in my opinion, and this is something that still in the world of optical communication is not addressed completely, in my opinion.
Very interesting. Well, excellent perspective. Thank you so much for making time to be here today. If someone wanted to learn more about SatEnlight, what should they do?
Well, of course, follow the LinkedIn page of SatEnlight and stay updated looking at our website, SatEnlight.com. But of course, also reaching out, because we always love to talk with people that are interested and that have good ideas on what we are doing. So actually, Matteo.Vismara@SatEnlight.com is my email. So if you want to reach out, feel free to do it.
Fantastic. Matteo, thank you so much for making time to be here today. It
Thank you,
was
Lisa.
an inspiring conversation.
Thank you very much, Lisa.
Absolutely my pleasure, and I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com, and we'll see you next time on the Tech and Space Leaders Show.